Hello everyone, welcome to the next video about color simulator. In this video we'll go through the basics of controlling the simulator from Python, and you will see the very basic sort of building blocks, how you spawn or start a car, how you set it on autopilot, how you load different environments and all that kind of jazz. So before going into that, I would like to give a shout out to the color channel itself. If you look into this particular video, this is how this video explains really well how to set up the camera, and that's where I got most of my sort of basics that I will show you, because at this point I just wanted you to see one camera, front-facing camera, rather than go in all varieties of different sensors and lidars that you can have on the car. So also my shout out goes to Sendex, of course. He's done a number of color video a while back, 3 years ago. He was making a series on reinforcement learning with color. So he's jumped into building reinforcement learning approach to driving, and in my videos I would like to focus on sort of building blocks to get you started before you jump into that deep stuff. Okay, let's get started. Of course, as usual, we need to start the simulator itself, and while it's starting we need to launch Anaconda prompt, which I showed you before how to install. We arrange all windows like that, and then we just need to go to in my case, to the folder where I keep everything. Effectively, it's just a copy of my GitHub repository. And then if I go, I've set up this folder on C drive called self drive. And as we get here, we need to activate our virtual environment, which we do by typing activate color sim. You may have named the virtual environment differently, but it doesn't matter. Like, you activate that one, whichever one you've got. And because we've got Jupyter installed, we can just run Jupyter Notebook. Which launches Jupyter server itself, and you can see your notebooks here. I've created a little tutorial notebook here. I go in it and we'll go step by step. All right, so the first things we need to do in Python is to import libraries that we're gonna use. And anything in Jupyter Notebook, if you hold Shift and hit enter, it runs that particular cell. So we've just imported color itself. That's the library that makes Python understand how to interact or use the how to effectively introduce color language into Python. Then the second one is just a normal random library, because we need to pick a spot to spawn a car. And we import CV2, which is a just to show you a basic image sort of library to show image from the camera onto the screen. And we use NumPy because it's used by color example to manipulate image, the actual image pixels and how it's represented, to be able to present it to you. The next one, this is a standard color command, and it's understood because we've imported color library itself. And unless you play around with your ports, it effectively communicates with the sim, which is running as a service on your machine through port 2000. And unless you play with your ports, I don't understand them. I just keep everything as is, and usually, unless you change it, 2000 works. The next one we've got is a command that shows you how to load different maps. So this one is 10HD, it's already loaded. So for example, if we go to town 05 and hit shift enter, this might take a while, and sometimes this one gives an error because it has a certain time limit to load a different town or to interact with the simulator, and this load part takes a bit longer, but eventually it gets there. And now you can see we've got a different town loaded, and that's a town of 5, which is where I trained my model, because it's got this circular highway going around town, which we can now see here. Okay, makes sense so far. The next one is we trying to use standard color commands to get. They've got this method called get spawn points. Effectively, for this particular town that is we've now loaded, town of 5. This command gets all the locations where you can start a car. And if we hit Shift Enter, so we already have it in this variable called spawn points, and which we'll later use to start a car, and by picking a random spawn point. Next one we need to get is there is a library in Scala where it contains blueprints. Blueprints effectively are just like, as they say, blueprints is something describes a particular object, and there are objects for cameras, for cars. There's something that they already pre-created for you. And you can also add your own car if you want to go through the trouble and follow all the procedures to do it, but I'm just using the existing ones. And this command will allow us to pick a car of the Mini brand, and we're now ready to start the car somewhere. And you can see the starting point is effectively becoming the location of the car, and it's picked as a random element from this list spawn points that we've done before here. So if we run this, so it ran this command where it tried to spawn an actor, and actors could be various things, and one of those things is a car. And the reason we use the first element from the list that we got here of possible cars is in case we have multiple instances of cars that are called Mini. So we're just making sure we just pick the first random one. All right, so the car should have started somewhere. We just need to find it on the map. And this is where we say, dude, where is my car? We just fly around the town and see. We're looking for a Mini. Where is Mini? Has anyone seen a Mini? All right, we need to go up and have a bit more view. Where is the car? Where is the car? Oh, there it is. Here we go. So the car has spawned in this particular location, and we can check later how long the list of all possible locations here. It could be quite a lot. So by picking randomly, it started a car in this particular spot. So the car is now not moving because there is nothing controlling it. So we've got a command here below that effectively enables the autopilot, and the car will start driving around. But before that, there is another object which is quite useful. So as we've been looking for this car manually by just flying around the simulator and seeing where it is, you can also use the spectator object in the simulator. Effectively, that is when you fly around and use the WASD keys, and that's your spectator view. So, for example, if we move around here and then run these commands, it should take us where the current starting point for the car is. And you can see it just took us right here where we started the car, and surprisingly took us inside the car, which is very cool. I've never seen inside the car. And then you can go around and again move the spectator view, and that's your spectator view right here, okay? And that's the object that you control it with, and by running this set transform command to the spectator, you move into a particular point. So you can pick any random point within this town, and running set transform, it would move this this view to that particular location. And we'll talk about transform object in later video, how it's what it's made up of. All right, so we're now ready to set this car on its merry way by hitting set autopilot true. Boom, as you can see, it's now moving by itself. Please note, this autopilot is a simulator autopilot. It comes with color. So obviously, as I said, the biggest advantage of a simulator is cheating, because you know and have access to all the telemetry from the simulator. So obviously you can use very simple rules-based logic to know where you are, what speed you go, and you name it, all the traffic lights, and then stopping at traffic lights, because you know from the simulator where they are, and you don't need to use any computer vision or any complicated stuff like that, because it's not the real world. So my point is, this autopilot is quite simple. Now the next point is where, again, as I paid credit to Carla video before, this is where the logic of setting up camera on the car that you can use for your self-driving tricks. That's the video of Carla channel itself. This is the one which I used for this particular sort of cheating shortcut. Couple of things here that are being set up. There are a couple of constants that effectively they define the offset of the camera, where it's mounted on the car, because when you get imagery from that camera, you need to make sure that like minimum of the car parts get into the view of the camera. So what this does, it lifts the camera 1.6 meters off the ground, and x-axis moves the car forward. We don't need the y-axis here, because it would move the camera sideways and wouldn't be centered in the car. So we're only playing with z and x in this case. And the next command is grabbed. There is a predefined object in color blueprint library, which is called camera RGB for red, green, blue. So that's a normal pixel of a digital camera sort of attributes. And then we setting up the attributes of the height and width of the camera. So we go in 360 pixels tall and 640 pixels wide. Interestingly, in version 9.14 for Windows, you need to stick to this sort of proportion, otherwise the cameras will not work. It's a bug, so you need to make sure the cameras started with this sort of aspect ratio. And then you set up the camera location, which is where you grab the location object, and when you spawn the car, it will be a location of the car, or the camera. The spawn the camera, it will be a location of the car. And if you adding up the offsets that are coming from these constants. And next, you define the callback method of the camera, and that's something that is part of the whole color setup, and that's what I got from that video that I showed you before. By following those steps, it's sort of does some reshaping from what I can see, because the color camera comes with not just RGB, like extra 3 channels, because obviously the dimension of pixels will be like you have the width and height of the camera, but also you have the typically 3 dimensions for all 3 colors, RGB, but they also have alpha channel, and that's why it's 4. So there is this callback method that is reshaping it. I'm not quite sure what it's for. I was just copying how they've done it. And then this is also the bits of code from I took from there. Camera data effectively is a dictionary of the pixels that is being passed on as the camera is being is starting to broadcast its images. And the actual thing that starts the camera is this method called listen, and listen kicks off, it effectively starts the live stream of the camera. So if we run this code, we've just set up we started the camera, we mounted it on the car, and it started broadcasting images. We just need to intercept it. And the way we do it is because we've imported CV2. So what we do is this camera data dictionary is an object that's effectively being updated in live. So if we grab it at any point in time and assign it to this image variable, then we can, using CV2 image show, we can show the image on the screen. And then if we run this is how we just getting a snapshot of what we can see from the car's camera. And then if we close it, and remember the car was, from what I could see from that image, it was waiting at a traffic light. If we hit it again, it's still waiting at the traffic light. And here, every time we need to close it. And it's waiting for us because we're using this wait key with 0 parameter. And then if we hit again, yep, it's still red, but it's going green very soon, and the car should start moving. And if we get the next image, yep, the car is already somewhere else. So these are the snapshots and how we get it from live imagery of the car. So that's probably enough for today, but before we go, we need to clean up. So this command here will stop the camera because the camera variable now is pointing to that front-facing camera on the car. So we need to run stop and then we need to run all the destroy methods that already exist in Scala. So we just need to, this code destroys for all vehicles in town, and then this code obviously does it to all sensors, and every time otherwise the sensor object will still be going. So before we do that, let's find where the car is by using this spectator method again. So the car is here. No, I forgot. Spectator method is only remembering the initial position of the car. But before we clean this up, let's find the car. And it's of course time to say, dude, where is my car? Okay, that's the car. I finally found it, and through the magic of video editing, you didn't have to suffer with me. All I wanted to show you is when you run this destruction commands, you can see that it removes everything from the simulator and the car disappeared just in front of you. So hopefully these little bits of code will allow you to get started with the simulator and start controlling, start a new car, maybe pick a different brand of the car, then set it off on autopilot and do the fun stuff, and then watch it and driving around in a simulator. You can also go into the examples folder of Scala, and you can run like generate traffic. And to do that, you just need to start a new Anaconda prompt and run Python space generate traffic, and it will start some new cars in the simulator for you. All right, that's enough for this video, and yeah, thanking you very much for your time, and look forward to see you in the next videos where we'll go into more in-depth topics of like maps and how you control the car and steering and acceleration and all that kind of jazz. Thanks very much for listening. I'll see you next time.